What's up, everyone? Press Reset Earth here. So today I'm going to talk about the flat Earth theory. Yes, it's been gaining popularity and a lot of momentum the past 6 months or so. And a lot of people are buying into this. And look, I've looked into the flat Earth theory. Now, the first little scientific proof I want to get into here is the fact that the moon actually is inverted depending on which hemisphere of the Earth you're on. So if you're in the southern hemisphere as compared to the northern hemisphere, the moon is going to appear differently because you're looking at it from two different angles. You understand what I'm saying? Because the Earth is indeed a globe. This wouldn't work in a flat Earth model. There's no way to explain this in the flat Earth model, because you're looking at it from two different angles. You understand what I'm saying? Because the Earth is indeed a globe. This wouldn't work in a flat Earth model. There's no way to explain this in the flat Earth model. You understand what I'm saying? Because the Earth is indeed a globe. The Earth is indeed a globe. Now, another thing that we can do to indeed, at least logically assume that we're on a globe structure is to just go out, buy yourself a telescope. Any amateur astronomer can do this. And just look at the planets, okay? And you can see that they are indeed spherical, and some of them even have moons orbiting them. And you can see this with your own eyes in a telescope, in a halfway decent telescope that you can buy online. We could even look at the moon and the moon cycles, which is caused by light from the sun reflecting off the spherical object of the moon. And you can test this yourself with a golf ball, shining it in a light, and you can see that this is indeed a sphere you're looking at when it comes to the moon. And you know, a lot of the flat earthers will say it's a disk, and you can disprove that by placing a disk in a light as well. And you know, you can't get those same curved shadows that you see on the moon, which is caused by light from the sun reflecting off the spherical object, the moon. Now, another thing we need to take into consideration is the Coriolis effect. This indeed proves that we are on a spinning structure, and there is no debating this, because snipers, for instance, and you can ask any sniper in the military, you don't have to go to a NASA website to figure this one out. They have to take into account the Coriolis effect when engaging in a long distance sniper shot, okay? And if they don't, they miss, okay?
High in the mountains of Afghanistan, a Canadian sniper will eclipse Reichert's 1-mile kill shot, taking out a Taliban fighter 1.5 miles away.
I don't know if they just thought that today was their lucky day, but it wasn't.
The sniper, Rod Furlong, longest kill shot in history, 1.5 miles. March 2002. U.S. forces launch Operation Anaconda. The mission, destroy Al-Qaeda and Taliban forces in the Shah-e-Kot Valley. Furlong's weapon, the Macmillan TAC-50, a sniper rifle with a max effective range of 2,190 yards.
The very first target we engaged was 1,500 meters. That was the closest target we would engage during Operation Anaconda. We want to be close enough to target that we can guarantee one shot, one kill. But when you're shooting at a human-sized target at 1,500 meters, there's so many variables to take into place.
Furlong works at elevations as high as 10,000 feet. The extreme altitude has a dramatic effect on long-range shots.
Every 1,000 feet you go up, it's a whole new set of equations. Because the air's getting thinner. So therefore your muzzle velocities are increasing, your time of flight is actually shorter from the distance further down.
Wind's played a huge factor with our hit ratio. Not a lot of one-round hits. Reason being is we're dealing with, at times I remember, at least 3 crosswinds. And you wait for that perfect moment. It's great if I can get the winds to die out, but how many times does 3 crosswinds die out? They don't.
Within a week, Furlong runs out of his Canadian-made ammo.
We had somebody offer us American-made ammunition. And when we started using it, we noticed that it was a hotter round. We're getting a lot longer distances out of this round. You know, whether that round was a lighter round, whether it was a faster burning propellant, I don't know. Every shot that we made was new for us.
Whether the U.S. rounds are more aerodynamic or simply have a faster burning propellant, the results are dramatic. Furlong and his team take out enemy targets more than a mile away, but his longest shot is yet to come. The Shah-e-Cote Valley, mean altitude 9,000 feet.
When somebody's walking on a river valley floor, I'm up at 8,500 feet. I'm looking down. It's almost like being on the clouds, looking at someone. We had observed a 3-man Taliban team, and one of them had an RPK, which is 7.62 machine gun on shoulder. And it was decided that we would engage the Taliban fighter with the RPK on his shoulder. My partner lasers the target, gives me the distance. He starts to give me bearing, wind direction. It's everything I'm using to enter in data into my scope, or in this case, what am I going to do to be able to reach that range.
You're talking about a 1.5 miles distance, and they're looking for a man-sized target on the side of a mountain. Now, that in itself is quite a feat to actually find that guy in the first place.
Furlong looks for any way to get more distance on his shot. He resorts to an old sniper trick.
It was a very warm day. We had our ammo laid out in the sun. Anything to increase range. It's not going to make a huge difference, but it will make a little difference for how propellant acts. A faster burn, allowing the round to travel slightly further.
Because of the extreme angle and the distance, Furlong uses the ambush method, leading the target or allowing it to walk into the path of the bullet.
I max out my elevation drum. My windage is maxed out. So I'm halving up my scope, and what I mean by that is I'm leading with my mil dots, but I'm also using my mil dots for elevation as well. So I'm kind of halving my scope to where I believe my point of aim is. When you have a scope, usually this is what everybody's thinking about for a point of aim. If I'm leading a target and I have a target walking from right to left, he's walking and I'm waiting for him to hit this point right here. Once that target is at my point of aim, that's when the shot's released. That's an ambush. You're not releasing on the crosshairs. You release, this is what you're using for a point of aim, and that's 1 mil. Basically, with a 4 mil lead and a 4 mil for elevation, your point of aim roughly would be in this area.
Furlong aims 4 mils, or roughly 15 feet above, and approximately 4 mils, or 15 feet to the left of his target. These holds compensate for bullet drop, wind, and spin drift.
And this is 100% not debatable.